Hello students, I am Dr. Parin Sheikh from LG Institutes of Applied Sciences. This is my fourth video lecture on group symmetry. In this video lecture, we will discuss remaining classification of the point group. Now let's begin. In last video lecture, we have discussed about what is point group and the classification of the point group. Classification of linear molecules and higher order axis containing point group we have discussed. In this video lecture, we are going to discuss remaining classification of the point group. Third classification, that is group of low symmetry where Cn absent. If Cn absent in the molecule, it further classified according to if E only present, E and sigma present, and E and I present. If only E present, the point group will be C1. If E and sigma, then the point group will be CS. And if E and I, then the point group will be CI. Now, for better understanding, let's take one example for the C1 point group. Here the example of bromochlorofluoromethane. This is structure of the molecule. Here one should know the structure of the molecule. Then we can identify the symmetry elements and point group of the molecule. Here there is no symmetry element present except C1 because this is asymmetric molecule. Second, that is CS, in which there should be one sigma and E. The example of chlorofluoromethane. In this molecule, we can see that these two hydrogens are bisect by this sigma plane. So the point group is CS. Next, CI. Let's take an example of staggered bromochloromethane. This is structure of the molecule in which there is one center of symmetry I present. So the point group will be CI. Next classification based on highest order rotational axis present in the molecule. Cn present. Then next, is there any Cn perpendicular and C2 symmetry element present in the molecule or not? If no, then this belongs to C type of the point group and it will further classified into Cn, Cnv and CnH point group. If molecule has no sigma V, so the point group become Cn. If molecule has a sigma H, then the point group is CnH, and if the molecule has sigma V, then the point group will be CnV. If molecule has Cn perpendicular and C2 symmetry elements, then it belongs to D type of the point group and it will also classify further in Dn, DNH and DND point group. If molecule has no sigma, then Dn point group. If it has one sigma H, then DNH point group. And if it has sigma D plane, then it becomes DND point group. Now here, there is no point group as CND and no point group as DNV. Let's take some example for the better understanding. First, C type of the point group. Here the example of water molecule. First, is there any principal rotational axis present? Yes, it is C2. C2 present in the water molecule that we have discussed earlier. Second, is there any Cn perpendicular and C2 present? No. So it belongs to C type of the point group, where Cn, Cnv or CnH type of point group may be there. Third, is there any sigma H? No. Fourth, is there any sigma V? Yes. Water molecule has sigma V. So the point group of the water molecule will be C2V. Here, symmetry elements for the water molecule for C2V point group. Next, let's take the example of ammonia molecule. First, is there any principal rotational axis present in ammonia? Yes, there is C3 rotational axis present in the ammonia. First, one should know the shape of the molecule. Here, the shape of the ammonia molecule is trigonal pyramidal. Second, is there any Cn perpendicular and C2 present? No. So it belongs to C type of the point group. Third, is there any sigma H present? No. Fourth, is there any sigma V present? Yes. Ammonia molecule has 3 types of sigma V present. So the point group of the ammonia molecule is C3V. Here, symmetry elements for the C3V point group. Next, the example of trans H2O2. First, is there any rotational axis? Yes, there is C2 rotational axis present in the trans H2O2 molecule. Second, is there any Cn perpendicular and C2? No. So it belongs to C type of the point group. Third, is there any sigma H? Yes. Here we can see that one sigma H present in the trans H2O2 molecule. So the point group will be C2H. Here, symmetry elements for the trans H2O2 molecule. Here there is one center of symmetry I element present in the trans H2O2 molecule. Next example, that is of boric acid H3BO3. This is structure of boric acid. Is there any principal rotational axis present in the molecule? Yes, it is C3. Next, is there any Cn perpendicular and C2? No. So it belongs to C type of the point group. Third, is there any sigma H? Yes, here one sigma H present in the boric acid. So the point group will be C2H. Here, symmetry elements for the C2H point group. Next example, that is for D type of the molecule, D type of the point group. Here, the first example, that is of naphthalene. In case of naphthalene, there is one C2 principal rotational axis present. Second, is there any Cn perpendicular and C2 present? Yes. So, it belongs to D type of the molecule. Here, one C2 that perpendicular to principal rotational axis, and this is second C2 that is perpendicular to principal rotational axis are present. Third, is there any sigma H present? So yes, here we can see sigma H is there. Is there any sigma D? No. So the point group will be D2H. These are the symmetry elements for the D2H point group. Next example, that is of BF3 molecule. In BF3 molecule, the principal rotational axis is C3. Is there any Cn perpendicular and C2? So yes. Here, so it belongs to D type of the point group. These are two C2 that are perpendicular to the principal rotational axis. Next, is there any sigma H present? Yes, there is sigma H present. Is there any dihedral plane? No. So the point group become D3H. Here some symmetry elements are for the D3H. Here 3 sigma V also present in the Beer3 molecule that we have discussed in previous video lecture. Next example, that is of allene. In case of allene, the principal rotational axis is C2. Here we are taking allene in the cube. Second, is there any CN perpendicular and C2 symmetry present? Yes. Here, so it belongs to D type of the point group. It is first C2 and it is second C2. Total 2 C2 are perpendicular to principal rotational axis. Third, is there any sigma H? No. Is there any sigma D? Yes. Here, these are sigma D. This is sigma D, which bisects the angle between two C2 rotational axes. Such 2 sigma D obtained in allene molecule. So the point group will be D2D. Here some symmetry elements. These are the symmetry elements for the D2D point group. Here 2S4 improper rotational axes are present. This is about the point group of the molecule. Next, improper rotational axis in detail we will discuss in our further video lecture. Thank you.